Good morning, afternoon, and evening, everyone. Welcome to Cassandra Lunch 120. We have a very, very special lunch in store for you today, so we'll just go ahead and get started. So today, we have a very special speaker, Johnny Miller, co-founder at AxonOps. He's going to walk us through Cassandra monitoring made easy with AxonOps. Hosts for this event are Rahul Singh and myself, Akwi Ohiri. We are looking for speakers and sponsors for this event. So if you're interested, please feel free to contact me at the email listed below. We are a part of Data Community DC. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome. And we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally surrounded around data. You can find out more about each of these groups at the websites listed. So what do we cover here? We cover everything related to Cassandra, Apache Spark. If this is your first time here, welcome. If it is your first time here, please go ahead and leave your name, how you found us, and what you're hoping to learn from these lunches. Just go ahead and leave that in the YouTube chat. A few group rules: if you have a question, ask it, be polite and courteous to others, and obviously we want you to share what you know with us. I like to defer to our speakers for when they like questions asked, so I'll hand it over to Johnny, and then he'll let you know when he'd like you to have your questions asked. But for the most part, you can go ahead and leave them in the chat, and I'll pass that along to him. So here at Anna, we help our partners design, build, and manage real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So I guess you could say Cassandra is our bread and butter. If you're new to this community, you'll find out pretty soon. All right. DataStax is a partner. We also have some program sponsors like listed there. We'd like to give a big thank you to our sponsors as well. And also a big thank you to our organizational sponsors. And then I also want to give 15 seconds for any jobs, meetups, hackathons, or conference classes announcements you may have. Please do leave those in the comment section below. And we are hiring here at Anant. If you're interested, please visit the website below for more information. And make sure you check out our events page so you don't miss any of the lunches we have coming up. We do have our Cassandra lunch every Thursday and our data engineers lunch every Monday. And we obviously have events in between then. So please check out our website and stay up to date. As always, our Cassandra lunches are streamed on YouTube. If you're looking for a lunch that we may have covered in the past, please visit our YouTube page. And also like to point you to cassandra.link. And finally, our latest Apache Cassandra runbook is available. So please go ahead and download your free copy. I'll go ahead and leave a link for that in the chat. And with that, I'll hand it over to our presenter today, Johnny. Johnny, over to you.
Hi, thanks, Akwi. Hello, everyone, and welcome. I appreciate you taking the time out to have a chat. Let me just share my desktop. Brilliant. Okay. Thanks, everybody. My name is Johnny Miller. I'm one of the co-founders of AxonOps, and today we're going to have a chat around Apache Cassandra monitoring made easy with AxonOps. And for your reference, if you'd like to find out more about AxonOps, you can look at our website, axonops.com, and you can feel free to reach out and contact us at info@axonops.com. So, and just to introduce myself, in terms of my background with Cassandra, I've been working with Cassandra for quite a while, since 0.6, which is really going back a while, and I've deployed Cassandra in a wide variety of places under different infrastructures, different security requirements, availability requirements, scale, etc. So I've been fortunate enough over the years to work on some really interesting Cassandra projects as well. So, anyways, cracking on. So just to give a quick brief introduction into what is Apache Cassandra for people here who might be new. So Apache Cassandra, what is it? It's a database, simple as that. And like any database, it requires stuff to be done to it to make sure it's there and available and servicing the needs of its clients. There's some specific nice characteristics about Cassandra, which is why we love to use it. It is highly available and fault tolerant. This is a fantastic feature in Cassandra. If you deploy Cassandra correctly and you look after it correctly, there's very few fires that Cassandra can't deal with and just keep servicing its requests and having a happy time. It's got a fantastic awareness of the topology you deploy it across. So it has an inbuilt understanding of data centers or regions, racks, availability zones, and it is completely masterless with no single point failure. It has fantastic latency and very high throughput, and it is generally horizontally linearly scalable. And it's also an open source project, which is also a top level Apache project as well. So it's a fantastic database. In terms of its adoption, it's out there, it's being used, it's been around for quite some time. Some of the biggest people in technology are using it, Apple, Netflix, etc. These are all running on massive, large Cassandra clusters deployed in a lot of different ways. So typical use cases we see for Cassandra are typically those ones where you have to be on all the time, you have to be highly performant, you're data intensive, and there's a good set of use cases that we commonly see for Cassandra. IoT, so lots of kind of sensor data, time series data, social media. It's fantastic, that kind of right heavy stuff. Telco, you see a lot of telco companies using it, particularly for all those kind of instrumentation aspects they need to have in place. It's very popular across all the online platforms, messaging, fraud, travel, etc. It's being used everywhere, and it's a really popular choice of databases. At a high level, these are the kind of top level things that you like. It's highly performant, it's tunably consistent, lots of different use cases. It's horizontally scalable. It has an inbuilt understanding of multi-DC region, completely masterless and totally open source and free to use. At a personal level, why do I love Cassandra? This is why I love Cassandra, because of its fundamental awareness of what it's deployed on. If you do it right, you will never have issues. It's one of the things that doesn't keep me awake at night with Cassandra. There's rarely any emergency that can't be dealt with the next day. And it's a fantastic database to run in production environments. And I really enjoy working with it. So, but it does all these fantastic things, but it's not magic. There's no secret special sauce here. It has to be looked after. And like any database there is, or any other kind of platform you use, it needs to be monitored. You need to know what's happening, where it's happening, and how frequently it's happening. It needs to be managed. There's certain things you've got to do on a regular basis to keep your Cassandra cluster healthy. You need to make sure it's backed up, and you need to make sure it's secured. And that's where the area that we're kind of going to focus in on our talk and demo. So, monitoring and managing Cassandra. This is one of those areas that over the years it's quite rich, and there's a lot of information you get off Cassandra that helps you know, is it healthy or is it not? And it also comes with a pretty fantastic bunch of tools that you can use, and we'll go through some of those at a high level, and I'll give you some demonstrations of things. So the first thing, anybody here who's using Cassandra or looking to use Cassandra is Node Tool. Node Tool is your kind of Swiss Army knife for Cassandra. This has a whole variety of things you can do on your Cassandra nodes and Cassandra cluster, but there is a lot there to do. There's a lot to get your head around. There's a lot of commands, and you need to have an understanding of what they do. So there's a fairly steep learning curve around it. But essentially, what Node Tool is it's a wrapper around something that invokes a Java process which speaks to Cassandra over JMX. And just to give you a quick example, so what I have here is I have a 3-node Cassandra cluster running in Kubernetes. with freeness in there. And no tool comes with Cassandra, and you can execute various commands on there. Here it's giving me the status of my cluster in the thing. And if you do no tool help, you'll see all of the various commands you can run with no tool. So this is something you're going to have to get your head around and understand all of these different things if you're going to be looking after Cassandra. So the next thing when you want to look at managing and monitor Cassandra is where you're going to get your metrics from. So Cassandra is essentially a Java process running in a JVM, and it exposes a wide variety of operations you can execute upon Cassandra, and MBeans that you can query to give you back metrics and instrumentation around everything that's happening on your Cassandra node. Now, there is a lot of JMX metrics available to you. They have a direct relationship to the number of tables. So the more tables and key spaces you have, the more metrics you need to be looking at to consume, capture, store, and run whatever you need to do to run against that cluster. But essentially, these are all exposed. They're available for you to look at and extract, and you'll be able to pull off everything from the throughput for reads, throughput for writes, to latencies, percentiles, histograms. It's extremely rich, and there's a lot of information there and available to you. So this is something you will need to get familiar with if you're looking to wire together something to monitor manage Cassandra, is really get an understanding of the wide variety of metrics that get exposed to you here. Okay. Other thing with your managing monitoring Cassandra, you're going to have to look at is the logs. So Cassandra outputs, as you'd expect, to a log file, and there are, despite having all of this fantastic information sitting in the JVM and exposed over JMX, there are still log files there, and these log files do contain information you want to pick up on and capture and look at, particularly when you're diving into any form of root cause analysis to try and understand what, I had a spike in whatever at this time of the day, what's happening, the logs giving me more fine-grained information. So logs are really useful, and Cassandra is pretty verbose with the logs, but you will definitely have to get familiar with the logs, what's in there, how they're coming out, etc. So, as you'd expect, with any database, you will need to be taking backups of that database, and backup management is one of the probably the most important topics with any database, is backing up your database and storing those backups in a location that you can restore your environment from disaster, failure, bugs, corruptions, hacks, whatever you like. But backups is an important part of any production Cassandra cluster. You want to be backing up your data. It is fantastic. It will tolerate enormous amounts of failure, but it still doesn't solve problems with, say, something going into production that shouldn't have, breaking things, etc. So backups are really important. Now, fortunately, with Cassandra, it provides you with some tools to take your backups. The first one is a tool that's part of NoTool called NoTool Snapshot. And what NoTool Snapshot does is it takes the snapshot of all of the Cassandra at that specific point in time. And then you've got to decide, what are you going to do with that backup? Are you going to leave it there? Are you going to copy it off server? What are your plans with that backup? The other thing at backups is around your commit logs. Cassandra has commit logs that get written to, and these can be archived to give you a point in time restore to specific points on what's happening on your cluster. So snapshots are usually the main thing people are often backing up with Cassandra, and there's a couple of things to be aware of that will trigger snapshot events on your Cassandra cluster. The first one, if you obviously call NoTool snapshots, it will take a snapshot on backup of the data on the local file system. If you drop a key space, it will automatically take a snapshot of that key space or table. This is an important thing to remember because sometimes it's very useful to have in production. I would never suggest turning it off, but in non-production environments, this is often something people forget to turn off, where you're dropping key spaces and tables as part of your CI or whatever. So you can often find those backups start to accumulate in those environments where people are just dropping tables, part of test scripts, test runs, things like that. So often you'll turn this off in non-production environments. You also have another flag, which is called incremental backups. And this is something you will probably never turn on. And if you do, you should really understand what you're turning on here. What this is basically, as Cassandra compacts the data, it keeps the old copies of the old SS tables. So if you enable incremental backups, you've got to think carefully about the volume of data, where this data is going, etc. And then you've got another piece of config, snapshot before compaction, where you can ask Cassandra to make a snapshot of the data prior to doing compaction. So the point-in-time recovery, this is often something people forget about, because snapshots are great because they'll give you a backup at, say, at 1 o'clock, 2 o'clock, 3 o'clock. But what happens if I want to restore to 1:30? Well, this is where commit log archiving comes into play. It's essentially very similar to lots of other databases, but you archive these commit logs off somewhere, and this is built into Cassandra, and you can use that to restore to that like half past the hour as you need to. There's a configuration file, commit log archiving properties, where you can set this up, and use where you can configure the restore time, and but typically snapshots are sufficient for most circumstances. I can count on my fingers the number of times I've seen some environments using commit log archival, but it is there, and it is useful to know about. But think about it. What are you going to do with all these commit logs? We're going to put them, etc. And this is repairs. So I'm guessing, well, I've been told everybody here is reasonably familiar with Cassandra, and repairs are one of the main operational activities you need to perform on your cluster on a regular basis. That's why I've put there in green with exclamation marks, must be run regularly on your Cassandra cluster. Now, obviously, there are circumstances where people don't run repairs, but those are run for reasons where they've made a decision based on something else to not repairs. If you don't know whether you should be running repairs or not, you should be probably running repairs. Now, how you run repairs is really important, because this is a complicated activity. It involves running a variety of commands on all of your nodes. And really the goal of the repair is to fix inconsistencies in your replicas of data across all of the nodes and data centers in your cluster. There is a wide variety of ways of running repairs. They can be run sequentially, in parallel, DCs. You can do full repairs, sub-range repairs, incremental repairs. You can control the concurrency of repairs. You can repair specific tables or key spaces, etc. And it gives you all of these levers to pull, because it is an important process, but also it is a process that can actually cause harm to your cluster. So I often have situations where I have prior to what I'm going to talk about, I'd have my cluster quite happily idling along, and I have my repair come in, start repairing my cluster, and then all of a sudden there's a spike in traffic or whatever, and I get a load of requests coming into my database, and then my repair is then competing with the transactions and requests for the client apps. And this is a constant issue and a constant challenge. And there is a wide variety of techniques and tools to help with this. And we will definitely be discussing how this works with AxonOps, and we'll definitely dig into this more detail. And feel free to ask any questions around repairs as well, because honestly, adaptive repairs in AxonOps is for me a great tool. I turn it on and I don't have to worry about repairs ever again. It's a very, very useful tool, and we'll get to see it in a bit. So, other thing that when you're looking at monitoring and managing Cassandra is the operating system. Yeah, the operating system is important. There are aspects of the operating system that have an effect on Cassandra's performance and correctness. So Cassandra, it is a fantastic database to write to, but only if you give it decent disks and you can get decent IO, etc. So looking at what the performance you're getting at the operating system level is also important. So you need to make sure you're not just instrumenting the JVM, you're instrumenting the OS, and you're then able to use that information to help you resolve any issues or manage or trigger alerts, etc. But you need to be having eyes on the operating system. The typical things you need to be looking at is your storage. Is it filling up? Is it performant? Are you getting errors? Things like that. The network. Am I flatlining, saturating my network? Am I seeing things getting dropped? All those type of things. The IO. Am I getting decent throughput? Am I getting decent IO on my disks? And most importantly, which is really important, is time, or NTP, network time protocol, depending on how you want to manage this. But as we all know, time is absolutely critical to Cassandra. Cassandra is a last write wins database. So if time is out of sync or drifting or not set up correctly, you will experience weirdness on your Cassandra cluster. So monitoring time, monitoring NTP, monitoring drift is something you want to be looking at, alerting on, and reacting to that when it happens. It also should be something when you look at deploying Cassandra that you look at, how am I going to be looking after NTP? How am I going to be looking after time on my cluster? It's something to take into consideration. And there is a wealth of material out there on the internet, plenty of blogs explaining different approaches to time synchronization, and there's tons of tools, etc. But really important, keep an eye on time. So got all this stuff in Cassandra, all these great tools and features. So why have we built AxonOps? So if we look at all of this stuff, I have to be looking at, monitoring, ingesting, dealing with. I have to take all this information and I have to put this somewhere. I have to interpret this information. I have to trigger alerts, etc. off this information. And there is a wide variety of generic tools out there and Cassandra specific tools out there that can help you do this. And AxonOps is one of them. Now, but prior to AxonOps, if I was going in to deploy a Cassandra cluster, once I've deployed Cassandra into production, I also have to put everything else in there to make sure that Cassandra is happy and being looked after. So, popular tool, Prometheus, Grafana, I love these tools. I use them all over the place. So if I was going to use Prometheus with Cassandra in a simple way, I would install the JMX exporter, the node exporter. I would deploy Prometheus. I would deploy Grafana, and I would start ingesting all of those metrics in there. And then similar things with like Datadog. I would install Datadog as well to give me that piece of information. I might use metric beats to take the log files, ingest them into Elasticsearch. I might need to use Graphite, etc., etc. A lot of tools to give you all of the necessary information you need to have to look after Cassandra. And where this often presents challenges isn't necessarily around the efficiency of these tools. It's more also around the challenge with not just looking after Cassandra and deploying Cassandra, but also looking after this plethora of tools that you need to also deploy, also monitor, also back up, also understand, to look after Cassandra effectively. And similarly with repairs, there's choice out there. You've obviously got node tool, which you can run repairs from the command line. You've got a tool there called Cassandra Reaper, which will kind of help run repairs in a way. You can write a bash script to run repairs, etc., etc. But again, no single tool to do metrics, to do logs, to do repairs. And the same thing with backups. You've got snapshots, Medusa, bash scripts, etc., to look after your backups. And essentially, what we were ending up with, lots and lots of tools, lots of complexity, and ultimately lots of cost. So, I've no problems with those tools, love them, But if I'm deploying Cassandra into an environment, or maybe you're somebody who's new to Cassandra, I want to be focusing my energy, my time, my efforts on Cassandra, understanding how to make Cassandra hum, tick, and focus all of my expertise on Cassandra. I often don't want to also become an expert in all of those other tools I need to look after Cassandra. And then once I have all these tools looking after Cassandra, well, I have to put in everything else to maintain the currency of these, update these, secure these, deploy multitude of agents across our service. And you can imagine going into like a restrictive environment, say like a bank, yeah, and you're deploying Cassandra, and then you have to also then install a whole variety of binaries and agents and tools on the operating system, open up a bunch of extra ports, et cetera, et cetera. And getting this type of change, it's often hard enough just to get Cassandra adopted, but you start throwing in a wide variety of disparate tools, it can become a challenge. So ultimately, what this was the driving force that made us kind of step back and go, look, this is where our energy's in the wrong place here. We're spending all our brain power on these tools, not on Cassandra. And this is really where AxonOps came from. So what is AxonOps? Well, if you haven't already seen it, you go to axonops.com. There's a ton of information there, but essentially AxonOps is a Cassandra managed tool hosted in the cloud by us. And it provides all of the observability, the alerting, the backups, the repairs, essentially everything you need to manage your Cassandra cluster successfully in one place. And also, this isn't a tool being built just randomly. Myself, Hayato, John, our engineers, we've been working, all of us, with Cassandra for a very long time. We've deployed Cassandra lots and lots of places. We've used lots and lots of different tools. And we really have distilled all of our experience and best practices into a tool that we use to look after Cassandra as well. So it's not just for the public, we use it ourselves for other clients to manage Cassandra as well. So we definitely eat our own dog food with Cassandra, and which is why we built it for ourselves. And then we figured, you know what, everybody else might want to benefit from this as well. So first thing about AxonOps is it is simple. This was intentional. The challenges we were getting with deploying all of these different tools and agents, etc., was really a driving force for this. So we took the view to make Cassandra as simple as possible for you to install and set up. And I'll show you how to do this as well. But essentially, all you do is you install a single agent, and that is it. All of the logs, the metrics, the tools necessary to manage that Cassandra cluster in production, all going through that single agent. We ingest an order of magnitude of tens of thousands of metrics a second, all of the logs, etc. We built this agent to be very, very, very efficient, very, very low footprint, because the other challenge you often get with installing all these things is, well, they are starting to compete with resources. So we put a lot of time into making the agent very, very small, very, very efficient, down to our own network protocol. So we have a bidirectional protocol between the agent and the AxonOps server, which allows us to interact over a single socket as well. So we can consume everything, but we can also act on everything as it happens. So we're able to communicate near real time, invoking things, doing things on the cluster while we're observing what happens as it comes in. So it comes with a bunch of pre-configured dashboards. So out of the box, sorry, I've got to, sorry, apologies. Out of the box, you get a bunch of pre-configured dashboards. These are customizable. You can do them yourselves. It comes with all of your backups. It will manage all of your backups for you, copying them off server to S3, SEP, Google, whatever you like. It's got intelligent and adaptive repairs, so we don't have to worry about repairs anymore. And we integrate with all of the tools we need to integrate with to alert or enact or raise incidents. So AxonOps will integrate with ServiceNow, Slack, PagerDuty, Teams, generic webhook, email, whatever you like. So it's very easy, simple to use, and it should be able to configure and interact with whatever tools you want to use around your manage your operations in general. So demo time. All right. So what do we have here? So I've deployed. So let's start with AxonOps itself. So if you want to sign up for AxonOps, pretty straightforward. You go to axonops.com, click Get Started, yeah, and then you'll be prompted to sign up, and away you go. At this point, I'm already signed in. So once I sign in to AxonOps, I get presented with a set of organizations to which I am a member of. So this is important because these organizations are groups of clusters that, and you have great ability to control who has access to what, invite new people to help you in your clusters. So let's look at the demo cluster we set up actually for Apache Cassandra the other day, but here we go. So I'm in that cluster, and then I have a bunch of options here. So I have teams, so I can invite people to join my cluster. And when I invite them to join my organization, I can give them different roles in that organization. So if I want to allow someone in just to have a look around and see things, I can give them read-only access, or I can, if it's someone who's going to be able to make changes and do DBA activities, we can give them different levels of access. So you're able to control essentially RBAC controls around the members of your AxonOps organization. So how do you install AxonOps? Very, very straightforward. You have to install our agent. So you get given an agent key, and you pick a key, one of these you want to use. The next thing you want to do is you obviously this is a wizard to just step you through the way of doing it. But sure, you'd be using Ansible, Chef, or whatever to follow these steps, but this gives you the steps you need to install the agent on your Cassandra server. So you pick your OS. I'm a big fan of Ubuntu, and there's the commands to set up the AxonOps repo and etc. You then pick, okay, what version of Cassandra? Well, we ain't going to use 3. Let's go with 4. And then essentially you do apt install Cassandra 4 agent. Once you install the agent, there is a configuration file on the agent under etc AxonOps agent YAML, and this is important because this is where you can configure all sorts of things around what AxonOps can do on your cluster. For example, it's recommended to configure the agent to point at the NTP server you're using, and this allows us to really efficiently calculate any form of drift we're seeing based on the host, based on what our agent's seeing, etc. You also have the ability to ship scripts to the server yourself, which then could be invoked by AxonOps, etc. But essentially, and this is all documented on the documentation side, but it's all sorts of things you might want to configure yourself there, and then you give that the right permissions. So our agent, you have to attach a Java agent to the Cassandra JVM to allow our out of agent JVM to interact with it. But simply put, you just add the Java agents to the JVM options in your Cassandra env, and it then reads the same configuration file that the agent installed on the OS does. Recommended. When you install things, it creates an AxonOps user. Recommended to add that to the AxonOps user group, and add the Cassandra user to the AxonOps user group, just to avoid anything strange happening on the file systems, etc. But once you've done that, you simply start Cassandra, start the agent, and then away you go. So what do you get presented with then? So let's go back to the cluster. So here's the one I prepared earlier, and then we go into there, and we have a 3 data center cluster with a bunch of nodes in each. So this is a Cassandra cluster deployed on Kubernetes, using AxonOps to manage it. It also, not just Kubernetes, but it will manage it in whatever way you choose to deploy Cassandra, but we've used Kubernetes here, and we have the Cassandra cluster deployed in 3 different data centers, all within Kubernetes with AxonOps managing it. So what's the first thing you see when you sign in? Here we give you a cluster overview, a visualization of all the clusters. So here's your cluster, here's each data center, and then from here you can interact with all of these nodes. So I click on this guy, I can see there's any alerts about him, or things about Cassandra, the JVM, etc. There's also a convenient list view as well, which will allow you to see all of the 24 nodes installed here, and then you could pick one and search there. So say, for example, we wanted to find out what are the seed nodes configured on this guy. Well, there's the seeds configured on the guy. Additionally, we're not silly. So despite you being able to search and query the Cassandra YAML, we do hide the important stuff. So obviously, if you have SSL enabled, we're not going to return the key stores, trust stores, anything like that. So it's aware of what's sensitive under there. And then you can inspect this node in a variety of ways: operating system, the Cassandra configuration, the JVM, everything you need to know is there, the heap, GC, etc. Any tasks that might be running on there at the moment. And one of our favorite tools, Node Stats. So Node Stats is something we put in there, and what it's doing is it's presenting a view inspired by DStat, which allows us to overlay all of the activity happening on the host with the Cassandra traffic coming in. So I can be sitting there looking at 10-second samples, seeing, okay, I have a spike in writes to disk. It correlates to something happening across the Cassandra reads and writes at the moment. I'm not sure there's stuff running in here at the moment, or in the wrong data center. So that's quite useful as well. But so going back to the cluster overview. So once we're in AxonOps, so let's go through the various operational things you would want to do when you're looking after Cassandra. So I mentioned before, we integrate with a lot of different things. So if you're configuring something to monitor, you're configuring something to alert, and other things. So we have the ability to integrate with a wide variety of tools. So email, SMTP, PagerDuty, Slack. I've set up a Slack integration prior to the demo, Teams, ServiceNow, generic webhooks. So what this means is you can configure AxonOps to, say, use Slack, and then any notifications will be routed through Slack. And you can also configure additional levels of different integrations based on what's happening. So you can have global, or you can maybe have a different integration for warnings and errors. Say backups. Say you don't want to be alert. Not everybody wants to be alerted when a backup fails. So you might set up a different route for those alerts for backups to go to a completely different integration. But essentially, you can have a multitude of integrations set up for different Slack channels, different PagerDuty teams, whatever you like. The other thing that we have from a monitoring perspective is we have service checks. So service checks allow us to run periodically certain checks on the host to check things are running. So as an example, it supports HTTP checks, TCP checks, and shell script checks. So what this is doing, we set up a check to say, check every 50 seconds that something is listening on the native transport port. So this will be run periodically, and if this fails, you'll get an alert. And you can set up a wide variety of different kinds of checks. And look, here's one going right now. We have an active alert happening. So it's something coming in saying unable to connect to the Cassandra agent. So let's do that. Anyways, so service checks in there. You can add a shell check. These are quite interesting. You have the ability to, let's say, for example, you wanted to run a check that checks, I don't know, the expiry of your SSL cert. So let's say check SSL. Yeah. So all I would do here is I would have a paste in the bash script. And what this is doing is connecting up on the address and port we're listening on SSL, and then runs a command to check that if the certificates being exposed are going to expire in a certain amount of time, then you'd save that, and then that would get run however you like. So pretty flexible in terms of the kind of service checks you might want to run on the cluster. So other things that you can do. So let's talk about backups and repairs. Operations, repairs. Repairs with AxonOps is, if there's anything that will make you want to use AxonOps, it's going to be the repairs. Repairs and AxonOps are absolutely brilliant, and I very love them. Simply put, what we do with repairs is we have this tool called adaptive repairs. So let's turn this on the cluster. Now, what adaptive repairs is doing, it is running very small sub-range repairs, And the load of those repairs is adaptive. So what we do is we're executing lots and lots of small repairs. And then based on what we observe on the cluster, we can increase or decrease, most importantly, the intensity of the repairs. So as I was mentioned earlier on, I kick off the repairs here. If all of a sudden I had a massive increase in load coming into the Cassandra cluster, the repairs automatically slow down. And this is really easy. And the other thing that the repairs are quite good at is if your cluster is idling, it will speed up the repairs. So it uses the resources dynamically and adapts to what it's observing on the cluster. And this is all because we're ingesting all of the information from the entire cluster to allow us to make very intelligent, informed decisions. Backups. Going back to repairs, if you don't want to use adaptive repairs, there's some different advanced configurations. This is all in the documentation. You can also run old school, simple repairs. You can schedule all of the different kinds of repairs you might want to run, full repairs, partition repairs, absolutely whatever you like. So if you want to run the scheduled type of repair approach, all of the schedule options are there as well. But typically, you just turn on adaptive repairs and don't worry about it anymore. Rolling restarts, something that you sometimes have to do in Cassandra. You have the ability to schedule a rolling restart. So maybe something's happening, you want to do a rolling restart at a certain time of the event. You can schedule these things to kick off. There's some smarts around how you want it to run the rolling restarts. You can also have scripts you choose to put in that actually this is how you stop Cassandra or start Cassandra. So it's how you choose to do it, but it will do all of the orchestration around perhaps restarting one AZ or rack at a time before moving on to the next one, and it can stop if anything kind of goes wrong, and it maintains a history. Backups. So backups in AxonOps are pretty straightforward. You can run backups for data centers, for specific nodes, for specific key space, tables, give them descriptive tags, and then you can also configure their retention of the backups it keeps, and you can also then point it at different targets for the backups to go to. So you can have remote backups going off to the local file system, S3, Google Cloud, Microsoft blob storage, and more. So essentially, you go in, you configure your backups, and it will then either just do the local snapshots if you like, or take those snapshots and then copy those backups off server. And what's important to mention about our backups is we are intelligently deduplicating the data in the backups. So we don't just copy the entire data set, we only copy the changes. And this is important for the amount of storage you need for your backups. So AxonOps is intelligently only copying up the new SS tables that have changed since the previous backup, and then it maintains a manifest of those SS tables, and that's how we're able to help restore. And then you can go into restore as well. Now, Cassandra, as I mentioned, AxonOps before, comes with a pre-built bunch of dashboards available for you to use and query everything you typically will need to know about your Cassandra cluster. This includes overviews, system information, CPU loads, cache hits or not hits as you don't want to see, compactions, what's happening at the coordinator, latency, throughput, etc. The CQL level, prepared statement is executed. And it gives you all of this very, very useful information out of the box set up by default. But also quite nicely, it gives you the logs as well. So you can see all of the logs coming in at the same time. So if I start, say I want to zoom in on a particular period of time, I zoom in on that, and then all of the relevant logs underneath here are there. And one of the things that is worth calling out is the performance of the way we do our graphing. So we developed our own graphing engine to render things efficiently, because one of the problems I had with Grafana was when I had a lot of data points on my dashboards in Grafana, it caused me lots of problems. I would be battling with Grafana as opposed to the problem I'm having to deal with. So a lot of time's gone in to making these dashboards very, very snappy, very, very quick. And another aspect of the dashboards is how they're set up. So if I look at this dashboard, you get a variety of things you can do with creating a new widget. So you can choose, give it a description, any documentation. You've got a different bunch of choices for how you want to visualize this. And as you'll notice, it's also PromQL compatible. So we're not running on Prometheus, but we've developed an interpreter for PromQL, which allows us to run PromQL queries across all of the AxonOps data that we get. So you're working with a syntax and language that you're possibly quite familiar with, and you can reuse that. And then similarly, if you wanted to set up an alert for one of these metrics, you just go to the alert definitions, add a new alert, pick what you want to get. Let's just create it. Off you go. We now have an alert created for this guy here. And this is really, really useful to have. We also have a view on the logs and events. So we're able to see everything that's happening on Cassandra. And it's not just through the system logs. We are capturing all of the events happening on your cluster. So as an example, if we go, let's do a real example. So let's select all the different sources and log files we want. And let's have a look for an authentication event type. So if I then connect up to my test Cassandra cluster, I run I'll sign in, I'll try to sign in. I'll sign in with a bad username and password. So Cassandra and Cassandra, boom. I get a username incorrect alert. And then, apologies, I've got the Zoom widget in the way. And then I go back into our dashboard, and we should see imminently, we should see our alert coming in. There you go. Connection refused. No, not that one. Logs and events. This is what live demos, as they say. Anyways. Okay, there you go. That guy's coming in. But anyways, you get an alert coming in on the logs, showing you everything that's happened. If I can just show you that. You can see all the repairs coming. Anyways, you get an alert coming into there. And other things we can do alerts on and trigger, as an example, is if I say I go in and I turn off binary. So remember that service check I showed you earlier on? That's checking if binary TCP is running. I turn this off. And we then have we should hopefully have an alert. I think I might have something else going on with my alerts. Apologies. Give it a second. There you go. So here's my alert that's come through, and it's saying I couldn't connect over CQL. And as you remember before, I set up that Slack integration, and then here you see the alerts coming in for the CQL port. And then if I go and enable binary, we'll see that come in a couple of seconds. And while that's propagating through, it's worth explaining. Oh, there you go, that's come through. We should have seen this. I think Slack's the slow guy here, but that's been resolved, and that's come through on the thing. Now, so yes, so we have the ability to essentially set up fairly complex alerting rules based on metrics, based on logs, based on service checks, based on backup failings, based on repairs failings. And you also see we store not just the logs, but also the various things that come out from the JMX calls, your node tool calls, etc. So when you're looking into what's happening on your cluster or what's happened on your cluster, everything you need to know is there and in one place to use. So, another feature we put in there, because this is something we get asked a lot to, is people like to have a report of the state of their cluster. So you have the ability as well with AxonOps to generate reports to be run regularly and possibly emailed out to people. And you can essentially pick a dashboard that you want to use. In our case, the reporting one, and then you create this PDF report, or you can set up a cron job schedule to run it, or you can do it in a way to schedule this report to be run, and then it will generate a report based on whatever you like, plus any other additional ways of filtering that stuff down and give it a tag. And you end up essentially with a report that displays everything you need to know in a reporting format that you can then use to send out to the people who need to know that information. So I think I'm running short on time. So is there anything, I suppose we've got time for let me just finish up the talk. So that's the demo on AxonOps, which I strongly suggest you go and try out. Additional resources out there, obviously axonops.com, all of the documentation for using AxonOps, setting up AxonOps, setting up your alerting, your logs, etc. is all there. We also have a AxonOps Slack channel, which I'd invite you to join. We're in there available to ask questions. It's a bit light at the moment because we've only just launched, but please feel free to join. And an FYI, always look at the Cassandra Apache org documentation and the GitHub location for that. So thank you very much. So are there any questions that people would like to ask? Akwi?
So it doesn't look like we have any questions in the chat.
Okay.
Let me just double check one more time. Yeah, so it doesn't look like we have any questions.
Well, if we have time to spare, I can take people through some more things. I'm always happy to show more. So how are we for time?
We have about 10 more minutes, 8 more.
Okay. So there's as I said, let's have a look at the different dashboards we've got there. Let's start with the overview. So you see a whole variety of things here that you can look at in there. We've got availability connections, number of tables. One of the things you might not know about, there are problems with Cassandra. The more number of tables you have in a single Cassandra cluster, and it is something you want to be able to alerting on. So you can have a quite simple alert to say if the table count ever goes above a certain level, you have latency statistics per node, where here you can see all the coordinator write latency, read latencies, etc. And in general, for your high-level metrics to be looking at and triggering alerts on, this is usually where a lot of them are going to be in the overview piece. Again, throughput, you can have very complex queries around how you're looking at throughputs over time periods, etc. Error statistics. If you're starting to see client any form of timeouts happening that you want to be picking up on, compactions per node. One of the common smells you get on Cassandra clusters is when pending compactions start to creep up. So you certainly want to be keeping an eye on pending compactions, and that's definitely one to look at. Adding alerts in to say if my pending compactions ever get greater than blah in a certain time period, you want to know about it. The systems, this is where I was discussing a lot of things that you really want to be looking at on the OS, the CPU, etc. And it's really useful to overlay this information with what else is happening on the cluster. So I can zone into a certain area of thing, and then I can see all of the different log events and such happening at that particular time ago. And you can filter what's in this view as well. It can be a bit, if it gets a bit verbose. Let's pull that back down. Cache, there's a whole bunch of caches in Cassandra. We've got all the key caches in there to monitor and alert. Because compactions are our friend, we have a whole bunch of dashboards specifically around compactions per node. Again, pending compactions, often something to be looking at per key space because it's typically workload related. Coordinator, again, these are a whole bunch of metrics, all related to the coordinator workload, what coordinator is observing around latency, throughput, connections. Let me change the time window for this. So this is a useful one. Coordinator reads distribution. So one of the things I often get asked is, how do I know what consistency level my applications are using to Cassandra? And with AxonOps, we can give you the information, a chart you need to know. So here I have most of my reads are coming into local 1. Here's one at all. Here's one at quorum. So we're able to actually see what consistency level people are using for reads and writes. And this is often the case. You get somebody saying, oh, we're using local quorum for reads and writes, but then you go in and you see they're using local 1. And the only way you really know how to, well, it used to be know how to figure this out was by asking the application team. So you have that in there. And also the error statistics from the coordinator perspective, you can set this up. Again, these are probably, if you're looking at alerting on kind of Cassandra client errors, at the coordinator level is probably where you might want to do it, but otherwise it might get a bit noisy for kind of false positives because of the way the replicas and everything can handle this. And if you are using lightweight transactions, all of the metrics you need to know about lightweight transactions, compare and set, and all the various type of conditions you can get. So we're able to show, okay, how many times was the CAS condition not met, or was met, or it's always been met. So I often use this to challenge lightweight transactions, saying, hold on, you're using lightweight transactions for this insert, but I look across the past month and I cannot see a single time when that lightweight transaction was not met. Are you sure you want to be using lightweight transactions? And it goes on and on. The data level, you see compression information, disk space per node. You can obviously filter by nodes, by key spaces, by tables, by data centers, etc. Dropped messages. Dropped messages is something you want to be looking at. This is where Cassandra starts to kind of back up and lose things. If you're a beginner, maybe it might be confusing, but you want to be looking into this and digging into it. So if I start to see a bunch of dropped mutations happening, I want to find out why. I'd zoom in on that. I don't know, what am I saying happening? And I can bring in obviously other dashboards to help me do the analysis around that. Entropy. We have a dashboard specifically around entropy in your data. And this is what helps us understand repairs not running, or etc. So we have a specific dashboard that's telling us what's happening with repairs. And this allows, okay, we're hinting loads, or we're always hinting, or how many read repairs have we tried? Have they been blocked? How many coordinator reads unavailable, etc., etc., and all the different thread pools relating to repairs. And then again, more dashboards to allow you to dig into specific key spaces, latencies, histograms, percentiles, the usual stuff. And then also on the table level, additionally, and then you go into the thread pools, all often very useful to have. You know, for example, if I want to see how's gossip getting on, well, I can select the gossip thing, and I can see, right, gossip's completing loads of tasks. I can see it doing a little bit of pending, and these are active tasks. And again, you can choose all the stuff. You can group by data centers, by hosts. So we can see all of the thread pools per host, by data center, if you're using racks, by rack, etc. And security. So we have specific stuff in around detecting the kind of standard stuff you might want to know around security. So failed authentications. So this is what I was showing you earlier on. This is how you would trigger, for example, an alert of someone failing to sign in, etc. So we capture all of the information around failed authentications. We also we can, if you want us to, we can capture DDL queries. So somebody ran a create table. That was the IP address they ran it from, etc. Any DCL queries, DML queries, authorizations, and then all JMX calls. So here you can see, this is the node to repair, calling JMX calls, etc. And as I mentioned before, there's the reporting window as well. So I think we're done on time, everyone. So really appreciate it. I hope it was useful. We love to get your feedback. We'd love to get people connected up and using AxonOps. Just go to axonops.com, sign up, and start using it.
Thanks, Johnny. Really exciting talk. I always love hearing more about AxonOps. I want to thank you again for taking the time to speak with us today. I'd like to thank everybody for joining us. Appreciate you guys taking the time out as well. And we'll see you guys same time, same place next week. Have a great afternoon, evening, and morning, everyone. Take care.
See you, everyone. Bye-bye.
That was fantastic. Take care, John.